This is section 4.5, and in 4.5 we're going to talk about isosceles and equilateral triangles. So I'm sure you've heard of these before. So some objectives here. We're going to use and apply properties of isosceles and equilateral triangles. So let's talk about what an isosceles triangle is, all the different parts and things like that. So, isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and design. Now, the congruent sides of an isosceles triangle are its legs. Notice the isosceles triangle. An isosceles triangle is a triangle that has two congruent sides. Okay, so the legs are the two sides that are the equal. Okay. The third side is what we call the base. This bottom down here is the base. The base is the one side that's the odd man out. The two congruent legs form the vertex angle. So these two legs right here form the vertex angle. These are all vocabulary words that you're going to need to know. You're going to need to know where the vertex angle is. You're going to need to know where the base angles are. Now, the base angles are actually kind of easy. The base angles are always the two angles that are opposite of the two congruent sides. So if I go opposite of those sides, those base angles will always be opposite of those two legs. Okay, so you got the base angles, and then you have the vertex angle. The vertex angle is the single man out, just kind of like the base side is the single side out. Okay, with that being said, let's take a look at a couple of theorems. First of all, it's the isosceles triangle theorem, and we're going to eventually put this in our tool belt with it as well. So it says here, if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So if we know for sure that AC and BC are congruent to each other, then we also know that the sides opposite of them are also congruent to each other. Again, the angles opposite of them are congruent to each other. So if I were to draw a line from those angles, like so, those are the two angles. So in this case, angle A is congruent to angle B. So if the sides are congruent, then the base angles are congruent. Now, the converse of that says is the flip of that. So if I know that the base angles are congruent, then I can say that the sides opposite of those base angles are congruent as well. So if angle A is congruent to angle B, then AC is congruent to BC. So the converse starts with angles, okay? And we're showing sides congruent. The regular theorem shows sides congruent, and we're making angles. Okay, so the things to remember with these two, because you will use these two in proofs. Okay, so the next part is the corollary to all this, and it says here a corollary is a theorem that can be proved easily using another theorem. So it says here, since a corollary is a theorem, you can use it as a reason in a proof. Okay, so the corollary, and to be honest with you, we won't use these very often in a proof, but I just want to show them to you because it is something that you will use in examples. If a triangle is equilateral, then the triangle is equiangular. Well, let's talk about what equilateral means first. Equilateral means that all three sides are the same, okay, or all of its sides are the same. Well, it's saying if all three sides of a triangle are the same, then all three angles are the same. Now, let's talk about this real quick a little bit. If all three angles are the same, okay, so let's say if I were to look at this here and say, all right, I don't know this, so we're going to make this guy x right here. That's x. So they're all the same, so they're all going to be x, x, and x. Well, I know that all three of those angles have to add up to be 180. It's a regular triangle, right? So in other words, 3x is equal to 180. And so if it's an equilateral and equiangular triangle, each angle will always be 60 degrees every time. Okay, so something that you might want to write down in your notes, that if you have an equilateral triangle, all angles are 60 degrees every time, all three angles. Okay. So again, if I were to erase here, this would be 60 right here. This is 60, and this is 60. Okay. All right, so then you also have the converse of the corollary, where it says if the triangle is equiangular, then the triangle is equilateral. So if all three angles are equal in a triangle, then all three sides are equal, vice versa. Okay, so these are the theorems that we're going to look at here in section 4.5. Make sure you check the next video out for your examples. I'll go through the examples so you know how to work the practice.